can't stay.
Hello everyone, welcome to Advanced Function Review. So today we're gonna go over some tips that are concepts that help me to learning, and I find that's very useful. You know, sometimes your teacher will tell you those math function, but you don't really comprehend it. So today we're gonna go over those tips, and I'm gonna help you to better understanding your advanced function, so you can have a better exam score. So the exam review. So the chapter 1. This sheet, I made this sheet. It just I have more details, but it's the same thing. But I'm going to go over from the chapter 1. Okay. So the first thing we're gonna know, what is a function. So this is the way. So what is a real function? It's just a special relationship for every single value of independent variable, which is x. There's only one variable. Okay. So example. Imagine there's a black box as function. You know, you don't know what's going on inside. You put an x input, and it will get a y as an output. Okay, this can be a simple function, and all the way to like very complicated function, like a rational function or exponential function. It's the same thing. Okay, and how do you know it's a function? Okay, there's a very simple way. It's called a vertical line test. So vertical line, if the graph, okay, can pass the vertical line, which means if you look at the function and look at the graph, and this is a line, if you go past it, and if they are contacting at only one answer at a time, it's a function. But if they have like this shape, if you pass the line, you see it kind of have a 2 point at the same time, which means they will have two answers, so it's not a function. So after we talk about what is really the functions, we know that you can only have one result at a time. So if you cannot pass a vertical line test, it means it's not a function. Okay, let's go to some basic concepts like domain and range. So what is domain? Domain basically just means all the x variables. So like say I have this function. It's basically like a linear function. So just like go from here. Okay, so it's like infinite. So what's a domain? It's like all the x. So it can go from negative infinite to positive infinite. So it's like domain is s is equal to all the real number. Okay. What is range? Same thing. Just y. The possibility is a limit for the y. Okay. And you write like this, and there's a different way of written the domain and range. So you first start with write this bracket, and this means it's okay. It's like x is equal to, if you write this, it's all the real number. Okay, and there's a different way to say that. Okay, so let's say this one is like x equal to all the real number, but x is a real number, but x is smaller than 0, smaller than 3, and bigger than -2. And this bracket means not including, and this bracket means included. Okay, so this one you can say is so this is the same thing to represent this graph, and this one is okay. You see this one. This means not included, but this the real dot means included. This one started it's like from -2 to 3, but -2 is not included. So it's the same it's different expression, but referring to the same thing. Okay, and then we talk about the whole and the vertical asymptote. We'll talk about that later in the next chapter. And then we talk about what's the type of function we have. Okay, we have a linear function. So it's just a straight line on the graph. This graph is going to be a straight line. Okay, we have quadratic. Quadratic is a parabola. It can upward and downward. Okay, let's talk about absolute value function. What is really absolute value? Just any, let's say negative y will have a positive y. So any negative number will have positive number. So your graph will look like a V. Okay, because if you look at it, okay, sorry, this is just bad terrible graph. So all the positive, okay, let's say negative 1, you can have a positive 1, negative 2, you have positive 2. You know, it's gonna be a V looking shape. Okay, you have a cubit, and we will talk about that later. So just like the biggest exponent is 3. Okay, quadratic, the biggest is 4. Okay, you have square root, rational function, graphs like that. We'll talk about that later. And you have exponential functions, and you have a piecewise function. It just like started from piece to piece. You know, it can be continued like this one, and this one, and it can be connected or not connected. But we will talk about that later. Okay, let's talk about exponent function. So there's you know, the formulas. It's just really look at the exponent. You know, you can have any exponent you want. Okay, and then let's talk about some properties. So you know, a lot of people, they're just trying to struggle to remember. Okay, how many the turning point they got? How many number 0? And you know, what's the end behavior gonna looks like? Don't worry about it. Either you will remember it. The thing is that it's like if you have n degree, you always have the most. Like you can, the most you can have is n minus 1. But how do you really remember it? If you look at this one, it's a quadratic, right? The exponent is 2, but they have 1 turning point right here. Going here, and you change the end behavior. Okay, so you can remember. Plus or minus 1 is equal to 1, and this one for the so remember also this is an even degree. Okay, they can at least have like 1, but for like even for odd degree function, this one is 1 example. So it's like just a linear, but so exponent is just 1. Okay, but this one, they have no turning point. You know, if you have a cubit which is 3 degree, it will also have no turning points. The trend is gonna be the same. You know, so you have no really turning point, so you can remember it. So by just remember the most simple graph you can think. Okay, so they can have 0 turning points, or 0, 1, so you can have 0. Or the odd function, they can just have no turning point, because if you look at this is the biggest exponent 3. It won't really have any turning point. And then let's talk about number of 0. Also, this one, they might have up to n0. Also same thing, just by remember the simple graph. Okay, it's 2 degree, you can have the 2 turn 0. Okay, and if that's a odd degree, yes, this is a odd degree. You anyhow, right? If you have odd degree, but this one or this one, at least you're gonna pass a 0. You know, at least you have 1. Okay, because anyway you cannot avoid to pass this way, so you always have at least 1 0. Okay, for the even degree. Okay, if you look at a quadratic as example, then you won't have real zeros, right? So you can remember by just remember the most simple graph, so you can remember those properties. Okay, and then let's talk about the turning point. So the end behavior. So always remember the function. Let's remember the just the normal function. It's always going from here to here. So let's say if you have a so the general the odd function gonna be like those shapes. They can vary as like they can be like that, and and the odd degree function is gonna be similar to the linear from here to here, but they can vary as be like this. So those are just the normal condition, okay. But if you think about the leading coefficient is negative, which means it's just gonna become negative. If you remember the linear function, this is the positive way, and if the coefficient is negative, it's gonna just be like it's just gonna be decreasing trend. So same thing to the to anything, to odd function. If you have a negative one, leading coefficient, you're just gonna have a negative trend. You're just gonna from like bigger to smaller. Okay. If you have a positive, like if that's positive leading coefficient, you're just gonna have similar. Just remember same thing with the linear. The basic trend is gonna be the same with linear if you have a odd degree function. Also, even degree function, just remember what the quadratic looks like. The normal quadratic is just like this. Okay, so same thing. If you have the normal one, it's just positive. You just gonna just looks like a normal quadratic, just upward. So you go through those things, and if that's negative, just draw a reverse way. Downwards opening. It's just basically the same thing, but just like they have a little bit weird curve, and that's how you remember. Just remember, like even odd degree, just linear, just very simple, and quadratic, even degree. So even degree polynomial function is basically the same thing. They just change it out. So yeah.
I can't stay.
So let's explain what is reciprocal function. So this is a parent function. Okay, this is very simple. We write the equation down. So then we go to reciprocal function. So what it really is that you just make 1 over sine of the original one. So your result will be 1 over the original y answers. So in summary, all the y coordinate of reciprocal function are the reciprocal of the y coordinate of the original function. So I write it down very simple. So you just, let's see, the x is minus 3 is equal to 5, and then the reciprocal function is 1 over 5. So it's very clear. Also, keep in mind, all your reciprocal function, the first thing you gotta do is you have to write the restriction always. Okay, now, and then you can see, you will always have a reciprocal function have a vertical asymptote at x at 0 of the original function. So why is that? Is this when it's as a 0, you won't really have a reciprocal function because you cannot divide it by 0. So that's why you will always have those vertical asymptotes here. So it's because you cannot have one. Okay, so and the reciprocal function will always have a y equal to 0 as horizontal asymptote. The original function is a linear or quadratic. So I will explain that later. It's because you will learn that later. You will always have this y equal to 0 horizontal asymptotes because you really cannot divide that. Okay, and then the reciprocal function have the same positive and negative interval. Of course, because if you look at it, it doesn't really change the negative or positive because you just use one divided, right? You won't really create another negative or positive, so they will be the same positive or negative with the parent function because you didn't divide or multiply by 1 or negative 1, so you won't really change it, right? Okay, and then the interval of the interval of increase on the original function or interval of decrease. So vice versa. Why would that be? If you look at those values very closely, right? The bigger they get, let's say 1,000, and then you 1 divided by 1,000 is gonna be very tiny number. So if you look at here, let's imagine this is 1,000. It's gonna be very tiny number, right? Vice versa, if this is a very big number, very small number, and you divide it, gonna be very big, right? Let's say it's like 0.0001, and you're gonna be a big number, right? So that's why it's like opposite with original function. Okay, and so this means the range of original function including 1 or -1 reciprocal function will intersect with those points. So very intuitive if you look at this, right? So this is 1 and -1. Why? What is the 1 over 1 again is equal to 1, right? What is this again? 1 over 2, -1 over 2, 1 is still -1. So that's why you will intersect, because same thing, 1 over 1 is still 1, -1 over 1 is still -1. So that's why you will actually intersect at those points. Okay. Also, this the last point of the reciprocal function. So local minimum will be the local maximum. Local maximum will be the local minimum. The same thing. It's just like this one. This thing, you know, it's if you, let's say a quadratic, right? So let's say you got this highest maximum point, right? Let's say it's 10, and then you 1 over this 10, right? It's gonna be the minimum. So it's the same thing. It's just 1 over those numbers. So the very big number we're gonna be very small. So let's talk about like rational functions. So first thing, for rational function, you have to remember you always need to have the whole. Okay, beware of sometimes, like, you know, you didn't kind of fully divided the full term. So once there is a numerator and denominator have a common factor, let's use this example. Okay, x minus 1. So those things are whole. They won't really exist on the diagram because they will kind of have a, like, this won't exist. So on the diagram we're gonna have something, you can draw a hole there. Okay, just indicate that. Okay, the vertical asymptote. So the vertical asymptote is this kind of looking. So this really won't attach to this point. It's because, okay, it's because the denominator is 0. So this means that you won't really exist because it's 0 on the bottom. You cannot divide it by 0. Okay, so one example is 2 over x minus 5. So the vertical asymptote is x equal to 5, because once x is 5, it's gonna be 0 on the bottom, so it won't really exist. Okay, so some people write in this term x cx plus d equal to 0. So it's exactly the same thing. So it just means on the bottom the denominator is 0. Okay, that you will have a vertical asymptote. It's gonna be looks like this. Now we have a horizontal asymptote or oblique asymptote. So what's really horizontal asymptote is this way. Okay, you really won't attach to this point because, okay, the reason is that I don't really know what's the reason, but I can tell you like how to find the vertical asymptote or oblique asymptote. Is you basically divided the numerator and denominator. So, you know, some people say, okay, you look at the degree. I just feel that you need to memorize a lot. So let's just use an example. Okay, so if you can divide, you can't divide it. Let's say this one. Okay, this is like it doesn't have a 1 degree and then it's 2 degree. You can't divide it. Then you get a horizontal asymptote because y is gonna be 0. You can't divide it. Okay. Okay. Another example is that they have same degree, and then you can divide it. So you will have this horizontal asymptote y equal to. Okay, and now this time you can divide it, and then you will get an answer which is you know, it's gonna be a linear relationship. So it's gonna be this or this way. So what is that? It's very obvious. It's like oblique asymptote. It's gonna have a line here, right? So it's gonna be like
the function is gonna be like symmetrical to or not symmetrical, but just divided because you have a line. Okay, and how you divide these things, we use a long division. Okay, you have a you can divide it. The numerator can divide it by the denominator. Okay, and so another thing is I don't really worry about the remainder, because this, in case what really the function is that you're gonna consider the infinite part. Let's say it's a trillion. Okay, it's gonna be a small number. So in the end, we're just gonna have those kind of just worry about this part. Don't really worry about the leftover remainder part. Okay, so you're gonna have a oblique asymptote. Okay. Find an inequality problem. Okay, so the first thing is we still have to write the restrictions. Okay, always remember this part, you cannot be zero, so we write the restrictions. Okay, also it's gonna be vertical asymptote as we said previously. Okay, so now you already can draw the diagram. Okay, so you know there is a turning point over here, so it's x equal 2. Okay, it's not gonna exist, so it's gonna be a vertical asymptote. Okay, and then we move to the one side, to the same side. So I move to here. Okay, gotta change to negative sign. Okay, once you divide it or like by negative, you're gonna flip the sign. Okay, just keeping that in mind. Okay, so this is like the common denominator is x minus 2. And you multiply this one, it's gonna be this. Okay, so you see you can cross out the same value, so you multiply at the same time, so we can make a subtraction. So you get this number. So let me teach you how to do the cross. So you write this one down. Okay, and this is negative 6x, and this gonna be negative 2x, and you plus together. Okay, it's gonna be negative 8x. Okay, and this multiplied together is 4. 2 negative, it's gonna be positive 4, and those multiplied together is 3x squared. Okay, so it's gonna be 3x squared minus 8x plus 4x. Okay, and then this sign we had, since it's negative, you have a bracket, it's changed to negative. Okay, and then we get this answer, and they have a common factor is 3x, so we can get these answers. And always remember that all the zero is at the numerator. Okay, so we know when x is 3, this part is 3, it's gonna be 0, right? When x is 0, it's gonna be 0 again. So there's 2 situations that are zeros. Also, we have another situation is gonna be a vertical asymptote. So I don't really know what the diagram gonna looks like, but I'm sure there's something happening here at this point, gonna turn up or turn down. Those are the turning point. Okay, so now we just plug in all kinds of numbers. Okay, so it's like infinite, from infinite to 0, and then to 2. It's all sections. Okay, it's interval. Okay, so from the infinite to the negative infinite to positive infinite. So now it's kind of fluid. So when x is infinite, negative infinite to 0, let's say negative 10, so this is gonna be negative, right, value, right? This is also gonna be negative value. This is also. So if you think about it, the final fx is gonna be negative 2. Okay, it's gonna be negative. So let's do this one again. Let's say this value is 1, it's gonna be positive. Okay, and this is gonna be negative because it's still smaller than 3. Okay, and then this is gonna be negative. So overall it's gonna be positive. Okay, if you look at it here, right, it's gonna be negative and negative, so it's gonna be positive. Okay, I'm just gonna speed up. Okay, so you get a negative again. and this is gonna be positive, 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 positive. And the question is that it's gonna be smaller than 0, so we're gonna find the negative answer. Now we know the answer is that the x will be smaller, so the question is so you write it down. 4, 2, when x is from the, okay, you cannot really including negative infinite because you can't, okay, and then you including to 0, okay, this is means include, this is not include, okay, and then you bracket 2, okay, that's the final answers we got.
I can't stay.
So I want to show you a very simple trick of how to remember primary trigonometry ratio. So a very simple way is you put your left hand on this table, and then so from the sum is 0 degree, 30 degree, 45, and 60 and 90. And then it's very simple. So for sine is any finger at let's say 30 degree, and then you find your right finger, like account from here to here. So you have one finger, and you square root it and divide it by 2. So let's check it. So it's gonna be one square root divided by 2 for sine 30 degree. Now let's check the cosine. Cosine is use this finger and the left side. So you have 3 fingers, and then the square root divided by 2. So it's gonna be square root 3 divided by 2. And let's check the answer. And it's right. And then let's do one more time. So you use 45. So sine are those 2 fingers. So it's 2 square root 2 divided by 2. And also for the cosine, because you use this side, so it's gonna be the same and correct. So this is one of the tricks that I use to remember the ratio and for special angles, and it's gonna be very useful.
I can't stay.
A lot of students can't really remember why sine function is like this. You start it from 0 and then go higher, reach to the top at 1, and then you go across to pi, and then finish at 2 pi. So the reason is like this. We have to remember what it really sine function is. Sine is a ratio, right? So the ratio is y over r. So it's gonna be this one over this one. So if we look at it, we started from 0. So at this point it's 0 because the y is 0. So that's why it started from 0. And then you imagine this from here, right? And we slowly increase to here. This is 90 degree, also is pi. So y is equal to 1 because y is, you move to here, right? Also, this is r, so it's 1, okay? We're gonna use a diagram to make it more clear. And then, so that's why you move it from 0, and then you move to the maximum is 1, and then vice versa, you go slowing down. So at 2 pi, you finish 1 circle. Okay, so cosine is the ratio that is x over r. So it's this one over this one. So let's look at it in the beginning. So if you look at this function, it started from 1 and then go to 0 and then finish the cycle. So at this point, cosine 0 is equal to 1 because at this point your y is your x is equal to your r, is because x equal to your r, right? And then you have you move from here and to here. So it's gonna be it's gonna be 0 because you doesn't have x value.
I can't stay.
So after we explain this one, so there's an equation that will be very helpful. So a lot of word problem you will find like sine or cosine. So actually if you look at this is a cosine function, right? So you will realize that this is a sine function. What really is the sine function is if you shift it to this point, it will be the identical with a cosine function. So just like I said, this is a sine function from 0 and then you to the pi over 2 and finish one cycle at 2 pi. Also, this is the red one is a cosine function, right? So you will realize if we can shift this function to here, that will be the same, okay? So this point is pi over 2. So that's why we can write this function, because this is the transformation of the function. Okay, let's talk about logarithm function. So what really logarithm is, it's just like an inverse function of exponential function. So what really is inverse function? You just switch x and y, right? So switch around x to the left side, y to the right side, okay? But the thing is that usually we put y to the left side. So what it really is, we invented logarithm, so it's log, okay? But the log cannot, the b cannot be 1 and it has to be bigger than 0. Think about this. If this is 1, any like 1 square is still 1, so it doesn't really have any meaning. And it also cannot be 0. If there's 0, you just won't have any answers. Okay. So in simple way, so log is just like the final answer and you're looking for exponent. Okay, for this as an example, so this is a base, okay, and this is base, and the final answer, you're looking for the exponent. So like how many times the 2 multiplied by 2 by itself can get 8 3 times, okay? The function is going to be like this. Since the inverse function is gonna reflect it on y equal to x, so it's gonna reflect it here. So there are some properties that will be useful during the calculation. So the first one is log b. 1 is always equal to 1. So think about it in another way. So any base, okay, and the final result is 1. So how many exponent it gonna be? It's gonna always be 0 because only 0 have 1, okay? And this one is log b and multiplied by bx. So the same that if you go back to the exponential function, you'll realize that really asking if this is a base and this is the final result. So what's the answer gonna be? It's like how many times was the exponent for b can get a b x root it's just x, so just x time, okay? And if you look at another one, this is a little bit tricky, so we have to go back to think about it. So this one is same with log bx, right? So it's just like this one just like if we go back, okay, it's just like let's write it. So y equal bx, okay, and then we're turning it around, okay, and then so
we turn into the log, it's gonna log b equal to y, okay? And then we treat this thing as the same thing, okay? And then we'll realize, okay, what is this part? What is this part? Is equal to y, right? So the final answer is gonna be x. And then we have the number 2, which is called product law. Okay, you don't have to memorize it this way, because if you know why it's like that, it will be much easier to remember. So very simple way is that it's actually a log. It's really just an exponential function. So if you know this law, you just reverse it. Okay, so this help you to remember. And this one is also a very useful function. That's actually a log that can help you. Okay, so let's prove it why it's like this. So we find anything scalar a square b square is equal to c. Okay, so, if we use the log, so we know the base, we know the final answer. We're looking for exponent. Okay. All right. So the same that if we turn in this function, if we also multiply by the same exponent d, okay, it's gonna be the same value, right? And also, based on the law, we know that the multiply b square b root b exponent is equal to bd. Okay. So then we can turn it around. We know we're looking for the exponent log. Okay. So it's pretty intuitive. This is the final answer. Okay. But now we know that we know what b is. Okay, the b is log a c. So if we can like substitute it into it, so we can get this formula. Okay, and now you actually just get d times log a c. So if you look at this, it's basically the same thing. You just put it into the front and multiply. Okay, the same thing. That's how you prove it. Okay, the last one is very useful, but this one is extremely useful for your calculator, because sometimes your calculator only have log 10, right? But if they're asking something like log 27 and 10, let's just say that. So for this formula, you can very easily do like can use a log 10, 27 log 10 to the oh shoot, sorry, it's wrong. It's b. This is on the bottom. 27. This is 10. Okay, and this you can just type it and you can get the correct answer. And this is the reason that the teacher don't tell you why this works this way, and here's why. Okay, so we find any log okay, log a. We presume, okay, we just presume this is the case. Okay, it's the same thing. We're just turning around into the log formation. Okay, and we all know that if this formula is divided by the same log, it's gonna be the same value. So let's divide a log b at the same both side. Okay. So and we know the previous law. We can move into the front. So it's gonna be y multiplied by log b a. Okay, and log b x. And then we're trying to get the y on a single side, so we can eliminate this by dividing this value log ba. Okay, and then this side too, both sides you have to divide by same value. Okay, and then this one we can cross is just y equal to log bx divided by log BA. And then you will realize that is the formula, okay? It's the formula. You see, this one is on the bottom, this one is on the top, okay? And you will just realize that's how the formula is. So very simple. The log, the base is on the bottom, and this part is on the top. Just keep that in mind.